Welcome to my channel. In this session now we are going to discuss about finding the Laplace transform of a function f of t is equals to cos 3t, and we are going to use the first principle in working out our function. By the first principle, this is what I mean. We understand that our function, the Laplace transform of a function f of t, is equals to integration with respect to our limits, the upper class limit and the lower class limit, which starts at infinity up to 0, exponential negative st we multiply by our function f of t, and our integration is with respect to time. Now, at this point, we understand that our function f of t is equals to cos 3t. So we are going to have the Laplace transform of cos 3t will be equals to integration with respect to our limits, exponential negative st we multiply by cos 3t, and our integration is with respect to dt. At this point, what we are being required to do is that we change cos 3t into an exponential. And by conversion of cos 3t into an exponential, we need to understand that from the complex number exponential theta j is equals to x is equals to cos theta we add to j sin theta, but our angle theta is equals to 3t, to mean that exponential 3tj is going to be equals to cos 3t we add to j sin 3t. At this point now we can come and say that exponential 3tj will be equals to cos 3t. Since cos 3t stands for the real side, we are going to introduce our r here and our r there. And we can come and say exponential 3tj will be equals to j sin 3t, which stands for the imaginary. Hence, we are going to introduce our I here. At this point now, we can get back to our working, whereby we say that the Laplace transform of our function f of t was equals to integration with respect to our limits. We have exponential negative st, we come and multiply by cos 3t, but here cos 3t will be equals to r exponential 3tj, but our integration is with respect to dt. To mean r, it is not a function of dt. We can come and factor r out, and we are going to have the Laplace transform of a function f of t will be equals to r integration with respect to our limits and our exponential. We are going to reduce the exponential part by using the laws of indices, and here it is a multiplication. So we are going to have exponential in bracket negative s we add 2, because of the multiplication we add to 3j, and we had a common term of t, so we will factor it out, and our integration is with respect to dt. Now from this point we can come and do integration, because we can come and now take our integration, and by doing the integration we are going to have the Laplace transform of our function f of t is going to be equals to, when we integrate whatever we are having there, we are going to have r into exponential negative s we add to 3j, we multiply by our function f of t, and since we are integrating, we are going to have negative s we add to 3j, and then we are going to have our limits, the upper class limit and the lower class limit. Let us now do away with the class limits, whereby we can come and have now the Laplace transform of our function f of t is going to be equals to r all over negative s we add to 3j, and here we are going to have exponential negative s we add to 3j, we multiply by t, whereby here now we are going to have the Laplace transform of a function f of t is equals to r all over negative s we add to 3j into exponential negative s we add to 3j. We come and insert the upper class limit to the term of t. We subtract from exponential negative s we add to 3j, and then to the term of t we insert the lower class limit. And we are going to have the Laplace transform of our function f of t is going to be r all over negative s we add to 3j into exponential raised to a power of an infinity. We are going to have 0, and here we are going to have 1. From this point now, the negative 1 is going to affect the function on the denominator, and by affecting the functions on the denominator, we are going to have r all over s we subtract from 3j as our answer. Now, at this point, we need to separate the real function and the imaginary function. For us to have the real function and the imaginary function, we must do rationalization. And by rationalization, we are going to have now the Laplace transform of our function f of t is going to be equals to r into 1 all over s we subtract from 3j. We come and multiply by s we add to 3j, and everything is going to be all over s we add to 3j, to mean that the function on the denominator we are going to multiply by its conjugate. So here it is a negative, here we are going to have a positive, and in case this one was a positive, we were supposed to multiply by a conjugate of a negative. Now at this point, we can come and have r into, on the numerator we are going to have s we add to 3j all over. On the denominator, let us open the bracket, we are going to have s squared. This one multiplied by this, we are going to have 3js. Here we are going to have, we subtract from 3js. And lastly, we are going to have, we subtract from 3 squared j squared. Let us solve the terms that we are having on the denominator. So we are going to have the Laplace transform of our function f of t is going to be equals to r into s we add to 3j all over. Here we are going to have s squared. Here we are going to have a 0 because this is a positive and whatever we are having here is a negative. We subtract from 3 squared j squared. But what do we understand from the complex numbers? We understand that j squared is equals to a negative of 1. To mean that when we replace here with a negative of 1, is going to affect whatever we are having here. So in case we insert here this a negative of 1 is going to affect whatever we are having here, this sign, and we are going to have a positive. At this point now we can separate the real function and the imaginary function. By separation of the real function and the imaginary function, now we are going to have the Laplace transform of a function f of t is going to be equals to r into, now we are going to have s all over s squared we add to, here we are going to have 9, we come and add to 3j all over s squared we add to 9. At this point now, what we need to understand is that our function f of t was equals to cos 3t. Cos 3t was located on the real side. And that is the reason as to why we are having here an r. Hence, we can come and say the Laplace transform of our function f of t is going to be equals to s all over s squared we add to 9. The reason as to why we are cancelling this side is because of the j. The j was located on the imaginary side. So we are going to cancel this side and have s all over s squared we add to 9 as our answer. And this is how you go about finding the Laplace transform of cos 3t using the first principle. You can be told to now you may be asked now to find the Laplace transform of, let's say, a function f of t is equals to, let's say, cos 7t. We understand that cos 7t is going to be s all over s squared we add to 7, but since 7 is being squared, we are going to have 49. 49. You can also be told to now find the Laplace transform of, let's say, cos 2t. Here we are going to have s all over s squared we add to 2 is going to be squared, and we are now going to have 4. And this is how you go about finding the Laplace transform of either 7t or cos 2t directly. But in case you've been asked to use the first principle in finding cos 7t, you must go through the whole process that we've gone through when we are finding the Laplace transform of cos 3t.